Part 6, how to determine the relative uncertainty of the dependent variable. Now, in our investigation right now, the dependent variable is the concentration or the molarity of vitamin C. So that's why we are going to determine the relative uncertainty. Like I have already explained before, there are two types of uncertainty, absolute and relative. Absolute if we just directly use one tool. Okay, so absolute uncertainty we can use it if we just use one tool. But to determine the concentration of vitamin C or ascorbic acid, we need to use several tools. So that's why instead of absolute, we need to use the relative uncertainty. Okay, and also because we used several measurement tools, so it means we are going to do the calculations. Okay, now so we are going to identify what are the tools that we used when we are going to determine the concentration of vitamin C. Now we can see from the formula below. Okay, before we have already found the average of NaOH and then determine the absolute uncertainty of IDV in this investigation, which is the different amount of sugar added. And then the third one is determine the concentration of vitamin C itself. Now take a look. When we use this formula, x1 times m1 times v1 equals x2 times m2 and v2, we can see that number one, it belongs to the ascorbic acid or sample. Now the tools that we use to measure the volume sample is the measurement tools, is the measurement cylinder. And on the other hand, number 2, it belongs to the NaOH. And V2 is the volume of NaOH. And then the measurement tool that we use is the burette itself. So that's why those two measurement tools that we are going to use it to calculate the relative uncertainty. Now, take a look. Volume NaOH, like we have already known that volume NaOH will be measured using the burette. Okay, and then we need to see what is the uncertainty of the burette. We can see from the table, the second table, the headings is 0.01, or you can go back to your case study and then take a look in the list of apparatus. And I have already mentioned there that burette has the absolute uncertainty, which is 0.01. So that's why let's just put it 0.01 plus minus, sorry. Okay, now next one is volume ascorbic acid or vitamin C. Now, according to the apparatus that we have already read before in case study, volume ascorbic acid or sample will be measured using measurement cylinder. Measurement cylinder. And then the uncertainty of measurement cylinder is 0.05. You can go back to the first sheet and then you can see in the list of the apparatus. We put it here first, yeah. Okay, next. Now, if we want to calculate the relative uncertainty of concentration vitamin C, we need to see which types of propagation of uncertainty that we have. It's based on the formula that we used in how to calculate the concentration of vitamin C. Take a look. Oh, the calculation include multiplication and also division. So if we want to find the relative uncertainty of the vitamin C, the first thing that we need to do, we need to find the percentage of each stool. Okay, so 3.4 is determine the relative uncertainty of vitamin C concentration. I just abbreviate CONT. Okay, so the first thing that we need to do is we need to find the percentage uncertainty of Buret. Sorry. Okay, because Buret, we use Buret to measure the volume of NaOH. Now, like I taught before, we need to put the formula first. Now, what is the formula? Now, I have already explained to you before how to find the percentage uncertainty of a certain tool. So, we can use the uncertainty and then divide it with value and then times 100. So if we want to explain or mention the sample, so it means we need to know which variation that we are going to focus. Now, for example, because we have 5 variations, so I will put 0 grams variation. Okay. Now, and after that, we can directly calculate the percentage uncertainty of Buret. The first thing that we need to do, we need to know what is the uncertainty of Buret. Now, this one, 0.01. So just mention 0.01 divided with value. What is value? Value is belongs to the average volume of NaOH. Now, in this case, we use 0 grams variation. So, if we go up and then take a look, this is 0 grams and then this is the average. So, the average is 45.6. So, we can put divided with 45.6 times 100. And then we can try to calculate it. 0.01 divided by 45.6 and then times 100. We got it, 0.02%. In here, I just use 2 decimal points, okay? Now, next, we need to find the percentage uncertainty of our second atau from our second measurement tool, which is measurement cylinder. Cylinder. Now, the first thing that we need to do, we need to put the formula. So we put percentage uncertainty equals uncertainty over value and then multiply with 100. Now, if we want to calculate the sample, so it means we need to put, okay, the variation 0 grams. Okay, but unfortunately, because we use the same value, because at the beginning, we use the same volume of sample, right? So that's why the variation doesn't affect to the calculation. Now, so just go to find the uncertainty of measurement cylinder. So this one is uncertainty of measurement cylinder. Okay, or this one 0.05. So sorry, 0.5. 0.5 divided by value. Okay, how many milliliters of the sample that we use? We can go to this one and then try to see the sample is only, go to the sample orange is only 10 milliliters. Okay, 10 milliliters. Okay, 10 milliliters. So we divide with 10 and then multiply by 100. So percentage, sorry, we don't need to mention that one. 0.5 divided by 10 and then multiply by 100. So we got 5%. After we get 5%, we need to add it or find the total percentage uncertainty. Total percentage uncertainty from both tools. So we just put percentage uncertainty from Buret, and then we add percentage uncertainty from measurement cylinder. Sorry. So 0.02% from here, and then we add with the 5% from here, and the result is 5.02%. That's the total percentage uncertainty. Now, the last one, if we want to find the the relative uncertainty of vitamin C concentration, okay, we can use the formula. Okay, we can use the formula. So relative uncertainty vitamin C equals the total percentage and then multiply with value. Now, what is the value, Pak? The value in here belongs to the concentration of vitamin C. But we have 5 variation. So that's why in the sample calculation, we need to mention the variation that we are going to put as the sample. Oh, for example, 0 grams, for instance. So we can put relative uncertainty vitamin C equals 5.02. I just changed the percentage into over 100 times value. So we need to see the value of vitamin C. Let's go up. Okay, this is 0, right? And then this is the molarity of vitamin C. Now, we do not use the pure sample because this belongs to dilution after you dilute 10 times. Okay, so you just use 0.46. So relative uncertainty of vitamin C concentration that has been, okay, we need to put here, yeah, diluted 10 times. Okay, it is I forgot, right? Wait a minute. It is 0.46. So we can write it down, 0.46. Okay, 5.02 times 0.46 and then divided by 100. So the relative uncertainty, the result is 0.02. I just used 2 decimal points. So this is the relative uncertainty of vitamin C. Now, this calculation, sample calculation, you need to put in your lab report. Now, the next one, Pak, how do we put inside the table? That's easy. So the first thing is we are going to measure the percentage of the first measurement tool, which is Buret. So take a look the formula. The formula is uncertainty of the Buret over value times 100. Okay, so we can use equals, open the bracket, you need 2 types the uncertainty of Buret. Oh, uncertainty of Buret is 0.01. Then we just need to type 0.01 over. Now, because the sample that not the sample, the one that I want to measure is 0 grams. So I need to select the average of NaOH volume belongs to the 0 grams. Okay, there is a dot line there, and then close the bracket. Don't forget we need to multiply with 100 and then enter. So you get 0.02. That's the same answer, right? 0.02 percentage. Okay, and after that we can just drag to the bottom by finding the black sign plus, and then we can get all the percentage uncertainty of Burat. That's happened if we want to find the second percentage uncertainty of our second measurement tools, which is measurement cylinder. So we just go back and then, uncertainty of measurement cylinder is the formula over the value. Now, in this investigation, the sample that we use is 10 milliliters. So it's easy, equals, just mention the uncertainty of the measurement cylinder, and then divide with 10, and then multiply by 100. Then we got 5. Okay, don't forget we need to drag to the bottom. And then we found the percentage of two measurement tools that we use to find concentration of vitamin C. The next one is if we want to find the total percentage, that is equals, open the bracket, just go to the first percentage uncertainty and then put plus sign, go to the second and then close the bracket and then we enter. And we got the total percentage. Don't forget, we just need to drag to the bottom. Now, if we want to find the relative uncertainty, remember we just used the concentration of vitamin C that has been diluted 10 times. So focus on the concentration of vitamin C that has been diluted. So equals, open the bracket, we select the total percentage because this is not in percentage calculation. So we need to multiply first with the molarity of vitamin C that has been diluted, close the bracket, and don't forget we need to over 100 and then enter. So we got the relative percentage uncertainty of the concentration or of the vitamin C. Okay, I think that's all. Thank you.